Okay, welcome to week, I don't know what week we're on, lesson 6 homework.
Week 4.
Not week 14, unfortunately, just week 4.
I'm counting down. I know the weeks.
Okay, so the preparation, we're supposed to pick randomly 5 numbers, and what was the mean of your sample? Jessica?
Okay, so that is question A, right?
Yeah.
Okay, I got 44,800
Ricardo,
for my mean.
what did you get?
Just 1 minute, I'm opening the document, okay?
So I got 43,80.
4380.
43,280.
Oh, 280. Okay.
So it looks like at least that both of us were within the standard. I was within 2 standard.
What are we reviewing right now? The homework?
Preparation,
Ah, the preparation. Okay.
just that random sample.
So we are talking about the mean of the 5 samples, correct? Of the salaries. I got a mean of 45,620.
So it looks like all of ours, so for C, it looks like all of ours fall within usual, so it's normal. And then, so what did we notice? Like we didn't all come up with the same mean, but we all are within the standard deviations. That's what I noticed.
Yes.
Okay. And then for number 8, A is, I've got bell-shaped, normally distributed, because it follows the normal pattern and the population is normally distributed.
Yes, I got normally distributed because the parent population is normally distributed.
Okay. And then
Correct.
okay. So now on to homework.
Okay.
Okay.
On to the homework. Okay, would you like me to kind of start going through it?
Sure.
Okay. So what is the difference between the central limit theorem and the law of large numbers? I had to look pretty closely at this, but my instinct said A,
That's what I put too.
because the central limit theorem talks about what happens to the shape of the sample means, and the law of large numbers describes how spread out it is.
Cardo, you got that? Just shake your head yes. Okay.
Okay.
I'm sorry.
It's okay. We'll let you do sign language today.
Which of the following gives the best explanation of the law of large numbers? And I got C. If the sample size is large, the sample mean will be close to the population mean.
That's what I put too. Ricardo? Okay. We're going to get through this homework today.
Okay, so for question 3, it says, suppose the mean internet usage time of all BYU Idaho students is 30 hours a week and the standard deviation is 4. This distribution is right skewed. Suppose a random sample of 4 students were surveyed concerning their internet usage. Use the information to answer questions 3 through 5. So what was the shape of the distribution of sample means? Because it was such a small sample number, I think it stayed skewed to the right.
That's
It would have been normal if the sample number had been larger, right?
Right.
Ricardo?
Ricardo agrees.
Okay.
Yes.
And then what was the mean of the distribution of sample means?
It's still
30 hours.
30. Yep.
And then the standard deviation of the distribution of sample means, I got 2 hours. You guys get that? 2 hours?
Yes.
How do you got that?
Oh, I didn't do the equation. On that,
So
I did the normal standard deviation. So it should be
well, all you have to do is you take the
right.
distribution, which is 4, and divide that by the sample size, which is 4, but that has to be squared.
Square root.
Okay.
Yeah, the square root of the sample size.
Yeah, 2. Okay.
Okay, and what was the shape of the wait, for the next one. Okay, suppose the mean internet usage time of all BYU Idaho students is 30 hours a week and the standard deviation is 4. This distribution is right skewed. Sample of 100 students were surveyed concerning their internet usage and assume that the sample was sufficiently large. What was the shape of the distribution of sample means? Now that should be normal because the sample size is large, correct?
Correct.
Okay,
And
the
the
mean
now.
is
Because
the
30
same, 30 hours. And then did you guys figure out how to do the,
Yeah. I don't know why I didn't do it on the problem before, but I did it on this one, and I got 0.4.
okay. Nice.
It's 4 divided by the square root of 100.
Right.
100 is the number of samples. Okay.
What I got.
Okay. You want me to do the next one?
Sure.
The length of human pregnancies from conception to birth is normally distributed with a mean 266 days and a standard deviation of 16 days. Suppose a random sample of 30 pregnancies were measured. Use this information to answer the questions. What was the shape of the distribution of the sample mean? And I put that it was normal.
Yes.
Okay. What was the mean of the distribution of the sample means? 266. That doesn't change. What was the standard deviation of the distribution of sample means? So, and I got 2.92.
So it's 16, which is the standard deviation, divided by the square root of 30, because it's the number of samples. And you got 2.921.
Right.
Superior.
2.92. Oh, and they said 3 decimal places.
Wait, what was your answer?
Mine
Yeah.
was 2.92.
Oh, I must have written that wrong. I got 9.
But then it said 3 decimal places, so I guess it should be a 1 there too.
Yeah.
Okay.
Okay.
Okay, number 12. Is the mean of the distribution of means greater than, equal to, or less than the parent population mean length of the human pregnancy?
Approximately equal
I
to.
put equal, yeah. Ricardo, did you get
Equal. Mhm.
Okay. Number 13. Is the standard deviation of the distribution of the means greater than, equal to, or less than the parent population standard deviation of length? And I put less than.
Less than.
The tendency is always to be less than. Mhm.
Okay, Jessica, do you want to do 14, then I'll do 15?
Sure. In a short paragraph, describe in your own words what the central limit theorem is. I just put, if the sample size is big enough, like 30 or more, the distribution of the sample mean will have a normal distribution.
Okay, that's pretty much what I have. So I've got, for 15, I've got the law of large numbers means that the sample size increases, the mean gets closer to the population mean. It's more accurate. The standard deviation gets smaller. The more samples that are taken, the standard deviation becomes smaller.
Okay. That sounds right.
Okay, Ricardo, any comment?
I can read what I wrote. It's almost the same. Central limits theorem explains that all possible sample means will have a normal distribution if the sample is sufficiently large. Normally larger than 30. Okay. And the other one is the law of large numbers explains if the sample size is large, the sample mean will be close to population mean.
Okay, got it. Are we ready for that quiz?
Oh yeah, the quiz. I'm not going to click on my homework one. I'm not going to.
I know. It's like, I'm going to learn. Group meeting quiz.
Oh my goodness. I did bad on the homework quiz last week.
I missed one. I missed like 3, and then I went back and I missed 1 after I figured out what I was doing wrong.
Well, he posted common questions that had been missed, and
Everybody missed that one.
yeah, I went back and hopefully I'm okay now, but I'm not very confident with that week.
No. Okay, we ready? Number 1 is true. 2, true.
1 minute, please. Sorry.
Okay, waiting for you, Ricardo. Let us know when you're ready.
Okay, I'm ready.
Okay. So question 3, when you're taking a sample size of 5, what is the shape of the distribution means histogram when the parent population is right skewed? So it's still going to be right skewed.
Yeah.
Okay. When you are taking a sample size of 100, what is the shape of the distribution of means histogram when the parent population is right skewed? And we said normal, right?
Yes.
Okay. Jessica, go ahead.
When you are taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? Normal.
Normal.
When you are taking a sample size of 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Normal.
Normal. Okay, 7 says, when would the distribution of means be normally distributed? Okay, so there should be 2 answers, I believe. Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that is right skewed and the sample size is small. Data are drawn from a population that is right skewed and the sample size is large.
So I think it's 3 answers there, right?
Yeah.
So 1,
3 correct.
2, and 4.
Ricardo, what do you think?
Yeah, the second one is a tricky one, but it makes sense that it's normal too.
Right.
Yeah.
If it's normally distributed, then the distribution means it's going to be normally distributed. Right? And if the sample size is large, even if it's right skewed, it's still going to be normally distributed. So I think there's 3 answers there, Ricardo, right? Okay. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. For bell-shaped data, approximately 68 of the data will be within 1 standard deviation. The mean, that's not it. We know that's not it. If the sample size is large, the sample mean will be close to the population mean. That's very large numbers, right?
Yeah.
If the sample size is large, the shape of the distribution of sample means will be approximately normal. That's what
I think.
do you think that last one, Ricardo? Okay. Okay. Use the following information to answer the next 4 questions. Let X be a random variable with a population mean of 10 and population standard deviation of 6. And suppose your sample is 36. So we have to do this little equation, so the mean, I have to write it all down to get it in my head. Okay. So
It's 6 divided by the square root of 36.
yeah. Did we all get one?
Are you answering question 9?
Yes.
Because I thought the mean would be the same mean. I thought it would be 10.
Oh, you're right. Sorry. The mean is the mean. 10. Thank you. I'm jumping ahead of myself. I'm going to do this math equation.
Okay, so now on question 10, then we do the math.
Okay, yeah. Sorry. I got one.
Calculator. So we're just doing 10 divided by 6 squared?
36 divided by 36 squared.
Oh, 36. Okay. Okay, 6. Sorry, I don't have it all right in front of me.
I know. I have to write it down so I don't lose it in my head.
Machines,
One,
ustedes son
one,
más
one.
rápidas. Y después tenemos unos capítulos.
That's what I got too. So,
Okay.
did you get one, Jessica?
Yeah.
Okay. Okay, regardless of the distribution of the population, if the sample size is larger than 30, what would be the shape? Because it would be normal, right?
Yeah.
They're really trying to hammer that into us that if it's a large population, it's going to be normal. But I need like 100 of these questions and I might get it. What theorem would justify your response to the last question?
Central
Theorem. If they could all be this easy, right?
I know. Now I feel like this next lesson is going to be so difficult because this one was enjoyable for me.
I know. Well, I don't know if enjoyable is a strong word.
It was soft. It was very soft. Let's see what happens.
Yes.
We know we're in trouble for Friday. That's all we have to say.
Yeah,
Okay, who wants this? Jessica, do you want to submit it?
I'm sure. No. All right, it looks, let's see, looks good. Okay, we got them all right, 100%.
Yay.
Yay.
Great, great, great.
Okay. Well,
Whoa.
we'll take a short one today, right?
Yes.
Yes.
Okay.
Sorry for the back sound. My wife is studying with my kids. He has a test, so he needs more studies than me.
That's okay. I'll send out the link for Friday.
Okay, thank
Yep,
you.
see you
Oh,
Friday,
thank you,
guys.
Michelle. Okay, bye, guys.
Bye.